In the next video, we'll discuss a geometric sequence, and we are going to answer 4 questions on the geometric sequence. So the first question is, determine the general term of the following sequence: 3, 9, and 27. So here we have the pattern 3, 9, and 27. And we can see we're not adding by a constant difference, but we are multiplying every single time by 3. So we can determine our ratio by saying term 3 divided by term 2, that is 27 divided by 9, which is equal to 3. And we can confirm whether or not that is a correct ratio. So we say term 2 divided by term 1, which is 9 divided by 3, which is also 3. So now we have established that it has a constant ratio between terms. Next, we want to find the general term of the sequence, and for geometric sequences, the pattern is a times r to the power of n minus 1. And in this case, the a value is 3. The r value is also 3 to the power of n minus 1. And because the bases are the same for these exponents, we can add up the exponents. So it's 3 to the power of n minus 1 plus 1. So the term is Tn is equals to 3 to the power of n. The second question says, determine the geometric sequence of which the first term is negative 3 and the fifth term is equals to negative 243. So we know term 1 is equals to negative 3, which is also a, and term 5 is equals to negative 243. But remember, the general term is a times r to the power of n minus 1. So that means negative 243 is equals to negative 3 times r to the power of 5 minus 1, because it represents the fifth term. Then I can see I can divide both sides by negative 3, that is 81, is equals to r to the power of 4. And I can rewrite 81 as 3 to the power of 4. Now we need to be careful. It might look like r is equals to 3, but r is equals to plus or minus 3, because negative 3 to the power of 4 is equals to 81, and 3 to the power of 4 is equals to 81. So the question said, determine the geometric sequence of which the first term is negative 3 and the fifth term is negative 243. And in fact, we have two different sequences, one for r equals to negative 3 and one for r equals to 3. So when r is negative 3, it is negative 3, which is the first term. Then I multiply with negative 3, so that's 9. Multiply with negative 3, that's negative 27. Then multiply that with negative 3, that is 81, and so forth. And when r is equals to 3, the first term is negative 3, then negative 9. Then I multiply with 3, that is negative 27. Multiply with negative 3, and multiply with 3, that is negative 81, and so on. So I have two sequences that looks the same, but in the first one, we can see that the signs alternate between every second term.